Hello and welcome to a new tutorial on how to use user data within Superfluid Super Agreements. I'm Sam, I help run developer experience here at Superfluid, and I'm super pumped to bring you this explanation today on how to build an NFT Billboard application using an often underutilized feature within the protocol. So user data is metadata, essentially, that you can add to any call that you make to a Superfluid Super Agreement. So as of the time of this recording, we have two super agreements. One of them is called an instant distribution agreement, and the other is called a constant flow agreement. When you make a call to the Superfluid host contract to initiate one of these agreements, what you can do is also pass in some metadata that's compiled as EVM bytecode. It's a bytes type in Solidity, and that user data can then be used and passed in to calls to super apps, and you can do a lot of other interesting things with it. So in this example, what we're going to do is build this NFT Billboard using Scaffold-Eth and the packages within Scaffold-Eth like Hardhat and React. And what we'll do is we're going to create an NFT Billboard that's very similar to the tradable cash flow example used in our super apps docs, where the NFT Billboard is essentially, think of it like a representation of a cash flow, where you can send a stream to this NFT, and then that stream is then just redirected to whoever owns the NFT. It's tradable. That's why the contract itself is called tradable cash flow. But the interesting thing about our iteration of this tradable cash flow contract is that we're going to allow you to pass in user data. We're going to show you how to do that, and that user data is going to become the message that goes on to this NFT Billboard. So as long as I'm streaming into the Billboard, my message will show up, and if I update my flow and also my user data, this message can change. So I'll show you how to do that, and yeah, let's get started. Alrighty, so we'll get into the basic project setup in a second, but first, before we do that, I want to go over what user data really is from a technical point of view. So user data is a part of something called context within the Superfluid protocol. So you've probably seen context. It's also abbreviated often as CTX. It's several places within our repo. So anytime I need to create a call to our super agreements and then ultimately our host contract, you are going to have the opportunity to pass in user data, which can become part of context. And then this context is then used kind of behind the scenes to pass information to super app callbacks. And it's also used for other things within the protocol, such as some basic governance items, gas optimization, and even some security items as well that get pretty technical. So just as a review of where user data actually exists in an individual call to a super agreement, I wanted to go through a quick review of the life cycle of a call to an agreement contract. So the first thing you need to do, just as a review, is you need to create a transaction object to either the create flow, update flow, or delete flow functions on a Superfluid CFA contract if you want to open or edit a stream. You do similar things with the instant distribution agreement contract. You just be calling the IDA, which is instant distribution agreement abbreviated contract, instead of the CFA. Sorry for the acronyms, but CFA, anytime I say CFA, is constant flow agreement. IDA is going to be instant distribution agreement. So then once I create this transaction object, then what I'll do is I'm going to call agreement, and I'm going to pass in that compiled transaction object as call data here. So really what I'm doing is I'm just going to create a call to create flow. I'm going to compile it. Then I'm going to pass it as bytes to this call data field. And then at minimum, I also need to have some kind of entry in for the agreement class. So I need the address essentially of the constant flow agreement or instant distribution agreement on the network I'd like to use. And then this user data can either just be passed in as an empty bytes variable. Often you'll see something like 0x or new bytes with a little casting around 0 passed in there. And you just pass in one of those empty values if you don't want to add any user data. But in our case, we are going to add something there. And user data can really be anything. I mean, there is a theoretical limit on how big of a value you can pass there, but you could pass in something like a message, like what we're going to do, so just a string. We've seen people use user data as a place to put an affiliate code for a Superfluid-based app around affiliate marketing and advertising. And you could even get as creative as putting the bytecode for another smart contract there as well. I don't see any reason why you couldn't do that. So again, please be creative with it. This is going to be a very simple example, but I would love to see somebody in the community build something really unique. So yeah, as a quick visual example of how this is all put together, I did want to go to our tradable cash flow example. So this is the tradable cash flow repo that was used in these super app docs, right? I highly recommend actually reviewing this tutorial before you come back to this one. That's written in the docs related to this video, but I did want to mention it again here. And you'll see here in the contracts inside redirect all, we have an example of a call that's made to create, update, or delete a flow. So here in this update outflow section, what you'll see is anytime we need to actually create, update, or delete a flow, what we're doing is we're essentially creating a call here. We're encoding it using encode with selector. In this example, what we're passing is new bytes of 0, which is just a placeholder value for user data. We're not using user data in this initial tradable cash flow example. And this value is passed as the second parameter to the call agreement function on the host contract. So again, just a good visual reminder, we're going to be using essentially almost the exact same contract here in our application, so we'll get pretty used to this. But I did just want to show you a little reminder on how calls are made to super agreements in the first place. When it comes to the context itself, though, what'll happen is, let's go to find my context example here. Where is it? Yeah, so I did want to show you what context itself looks like. So I'm going to zoom in here a little bit. This is inside of the host contract interface. It's iSuperfluid.sol in our repo. Context is a struct. So you'll see it abbreviated as CTX everywhere in the protocol. But really what it is it's just a compiled struct, right? That's often passed as call data, which is just essentially EVM bytecode to various functions within the protocol. And you'll see on the back end, if you read through some of our functions, what the protocol is doing is it'll decode context, see what was there, execute logic based on what was in context, compile it back down, and then pass it into different functions within the protocol. So to really break out context, you can go take a look at this on your own, but I did want to show you just how it's laid out. So some of these things around timestamp, call type, app level, these things are often related to super app callbacks. So we'll go into super app callbacks in just a second, but you should be familiar with them from the original tradable cash flow Holy Grail tutorial here in super apps. Some of this stuff is around governance, and then user data is listed right here. So this is actually just going to be a field that's appended onto the context struct. And what we're going to be doing in our application is waiting for context to be passed to a super app callback, decoding context, getting this struct, and then getting user data off of the struct, and then decompiling the user data. So there's a couple of steps there, and I'll make sure we walk through it. But really, like it's going to seem at first like user data is this hidden thing inside this other semi-hidden thing, but in reality, it's actually pretty easy to get to. It's just compiled for extra both technical reasons and efficiency reasons. So that's where context lives. And now I think it probably makes sense to go into some of the project setup items. So let's do that now. All right, so in terms of setup, the main thing we're going to need is Scaffold-Eth. So here I will link to the Scaffold-Eth repo, both in the description and the docs for this video. Austin Griffith, great community member in the Ethereum community. He's built a lot of really awesome stuff, like I think eth.build he built, and then Scaffold.eth is one of his brainchildren as well. So highly recommend playing around with Scaffold-Eth. To get started with it, you can just clone this repo I would highly recommend just doing that. What you get is 4 really key packages. You get Hardhat, React app, which is just built to create React app. You have some services, especially for things like running nodes and stuff like that. Then you also get a subgraph. We're not gonna, I shouldn't say a subgraph. You get information to help you manage a subgraph. We're not going to use services or subgraph. We're only going to use Hardhat and React app for today. But I do, like I said, highly recommend that you get that set up. And then we'll need 3 key NPM packages. I guess 2 key NPM packages, sorry. The first of them is going to be the Superfluid Finance contracts. So you can follow this page to get those installed. And then you're also going to need the OpenZeppelin smart contract library, but we're going to need a previous version. So go into versions and look for the most recent version with Solidity 0.7. So I would download this one, mainly because the Superfluid contracts, as they stand now, all use the Solidity 0.7.0 compiler. Once you have that set up, you're going to need 2 more things. One of them is going to be a private key that you store in an environment variable file, a .m file. Please keep your private keys safe. Do not push them to GitHub. Keep them as environment variables. Don't record videos like me and post them on the internet. It's a bad idea. But you're going to need that for actually making calls to testnets. We're going to make calls to live testnets instead of just a local Hardhat environment for this tutorial. So you do need to have that prepared as well. And the final thing you're going to need is some kind of RPC URL for the testnet you want to work with. This follow along is going to be all using Mumbai, which is the Matic testnet. You can get a Mumbai RPC URL through most of the big RPC URL providers. I've used Alchemy. So you can sign up for Alchemy on their site here. They're pretty good overall in my experience. You can create a new project. I have Mumbai here. And then if you click view key, you'll get a little HTTP link that we'll use as a URL within our application. So without further ado, let's get into it. All right, so now that we have our packages installed and we're ready to go, what we need to do is open up 2 split terminals. That's what I prefer to do when working with a couple of different elements here. I've run yarn start in this terminal to start our React app. And then I also have the rest of our repo over here. I'm just going to cd into packages Hardhat so we can start playing around in Hardhat. And you'll see here that in Hardhat config, what I've done is change the default network to polytest. Scaffold-Eth gives you a lot of different networks here. In my case, I'm using polytest, which is just Mumbai. I have the RPC URL here in URL, and then I have my private key with 0x prepended to it here in accounts so that I can actually use my account. All right, so we have that set up. And then in my contracts, let's get into the contracts themselves. So I mentioned that our project is going to be very, very similar to the tradable cash flow NFT project that we use with the Holy Grail example. This contract is almost exactly the same with a couple of modifications. One of those modifications is that we have 2 new storage variables here that we're going to use to, number 1, just take a look at what context actually is. And then number 2, we're going to set a variable to be that message that we're going to then display in our front end. Then what we're going to do is in our super app callbacks, we're then going to do something with the user data. So as you may recall, in the beginning of this video, what I talked about is how context is passed around to different aspects of the protocol when you make calls to super agreements. One of the things that happens when you create a super agreement, update a super agreement, or delete a super agreement is, the user data that you pass along with context is going to be included in the call to the super app callback from the protocol. So let's say you call agreement and you decide to create a new flow. What will happen is this after agreement created callback will be triggered and context will be passed here. This context you can then decode like we're going to do down here. And then we're going to then see what this context looks like. and then decode user data off of that context and this line and pass it back up to our user data variable. And then we're going to do a very similar thing, or actually the exact same thing pretty much, in after agreement updated to just update our message. And then in after agreement terminated, what we're going to do is just set user data to an empty string. So in each of these agreement callbacks, instead of just updating the outflow, we're also going to set the message that should be appended to the NFT Billboard, and we'll be able to see it visually on our front end. Okay, so next up, what we're going to do is deploy our contract. So all we need to do is just deploy tradable cash flow. What I've done here is I'm just using the hard hat deploy plugin that Scaffold-Eth has built in here, just in 0.0 deploy right up here. I've created a new file that just kind of mimics what Scaffold-Eth already had in here for deploying the your contract. And you'll notice in this repo I've left some of the Scaffold-Eth items in here in case you want to play around on your own. So what I have is just the Mumbai addresses for the host contract, the CFA contract, and f.x, which is just testnet super die. I also have an owner address that will just be the address that this NFT is minted to. It's another address that I have access to. And we're going to pass in the arguments we need to the constructor within tradable cash flow to deploy it. This get named accounts method, what it does is it's just going to set the account that our private key is associated to the deployer, so that we can deploy it from an address that we know has some testnet, Matic, and things like that allows us to deploy it. So what we need to do here is just call yarn deploy. Okay, now we can see that tradable cash flow has been deployed. We can copy this, head out to our browser. We can see that we have a new billboard here. The message is now gone. This billboard contract adjuster is changed. And if we go to Polygon scan, we can search this address, see that it was just deployed 26 seconds ago. We have the nifty billboard name, we have NFT bill as the symbol, and this is live. It's on a testnet, but we just deployed an NFT contract. Then what we're going to do is to open up flows into this contract, we're going to write a couple of scripts to allow us to create those flows. So I have some simple scripts here, just create, read, update, delete scripts, simple CRUD stuff. And what we're going to do in each of these is create a flow, update a flow, delete a flow, and then write a script to let us look into context on our end here in our terminal. So in create flow, and actually really all of these for that matter, I have just some simple variables defined up top that let us get contract abstractions using the ABI and address of each of our contracts that we need to call up top here. You're welcome to just copy and paste this or use this as just a fork from my repo. And then what I've done is I've also defined a Web3 object here. And what I've also done here is used a helpful pattern on Alchemy's website that I will also link in the docs as well for creating a new transaction object and making a call to the chain. So what I've done is I've defined a new function. This is the same pattern in each of these scripts. This function is called start flow because it's a create flow script. You'll see here that in this start flow function, I'm just going to set a call to create flow to a separate variable where all I do is I just call this CFA contract, which is, remember, the constant flow agreement contract. I make a call to create a flow. I pass in the token address, the address of the NFT, which is where we're going to be sending the funds, a flow rate here, and in this example, I'm not going to pass in any user data to this section, right? However, when I make the official call to call agreement, I am going to pass in user data. And to pass in user data, what I've done is use the web3.eth.abi encode parameter function to encode the string HODL as bytes. So you'll see that HODL is going to be what ends up on our billboard. Because who doesn't want to tell everybody else to HODL their favorite coins? But you'll see here the rest of this script we'll just make this call to the chain, and we'll see this flow actually be created in the Superfluid dashboard when this is finished. So let's call npx hard hat run scripts. All right, looks like this transaction has been submitted. And if we go to back here, we need to double check what the contract address is. So it looks like it's 0xb04 ending in 71f. If we head to Superfluid, to their dashboard, we can see that we have a new stream that is outgoing to the NFT contract, right? Those seem to match up. And then we'll also see that we have a new message here on the billboard. We can see HODL. This was not there before, right? Our user data has been decoded and added to our billboard. Now, if we want to actually see some more details about what this flow looks like, we can go to readdata.js. So here, same thing, same pattern, where I'm defining some variables here up top. So you also see here that I have two key variables we want to take a look at. One of them is called decoded context, and the other is called decoded user data. So I just want to show you what it actually looks like when we drill down into our two new variables here in a little node module inside of our terminal. So let's call npx hard hat run scripts readdata.js. I'll expand my terminal here so we can take a deeper look. All right, and what we can see here is we have just a couple of things that we've gotten as results. So the first thing that we are console logging is decoded context. That is what we see here, right? So we have app level, call type, timestamp, message.sender, which is just our address, agreement selector. User data is just this compiled value. And we have some other items here. But what we really care about is user data. We can see it's just bytes, right? A bunch of not very human readable things. So we have to decode this value again to get what we want out of it. So what we then do is we decode the user data, and we're going to console log that as well. And we can see here we have HODL, or HODL. Sorry to all the meme lords out there. But HODL is what's returned. And then we have some other things that I've console logged here as well, like the outflow rate, net flow into the NFT, the inflow rate into the NFT, and some other things around the agreement itself. We can see that user data is just a bytes variable that's appended onto context. And if we decide to decode user data, we get HODL. So again, just a couple of steps to decode things and get them out. But this should empower you to realize that anything can be passed into that user data variable. We want you to pass interesting things, even more interesting things than a message to hold on to your favorite coins. So what we'll do next is pretend that somebody wants to update the message on the billboard that they've been renting. So let's call the update flow script. And update flow, I'll minimize this a little bit. Update flow is very, very similar to create flow. All I've done is I've made a call to update flow instead of create flow, and I've just changed what the message is in our user data. Instead of just HODL, it's Hodl-Eth. So I'll save this. I'll expand our terminal a bit more. Then we'll call npx hard hat run scripts update flow. And what we'll also see here is that we have actually just increased the flow rate a little bit. So we'll be able to see these changes also take place in the Superfluid dashboard as well. So we can see, first of all, that our billboards changed. We now have a new message. And then second, if I refresh the Superfluid dashboard, we can see that in our activity history, we now edited this stream to be $17 per month instead of $10 per month. We can also see in a separate screen that the owner of our NFT is receiving funds from the NFT as well. We can see that their stream was also updated. And this is just proof that things are working the way they should be with our tradable cash flow billboard. Again, just as a reminder, the way that this works is you stream money into the NFT. The NFT is essentially listening for a stream to happen. Once a stream is directed into the NFT, it will redirect that stream to the owner of the NFT. And then if anytime the stream is then updated into the NFT like we just did, the outflow is then updated by a corresponding amount. If it's deleted, the flow is also turned off. And if the owner of the NFT decides to transfer, that NFT and all the cash flows that go along with it go to that new owner. So just wanted to show you that things are coming out the other side in the way they should be. All right, so final step here in terms of our scripts is to delete the flow. So same thing, same initial setup. The only difference is that we're making a call to delete flow, so that when we delete the flow, what I will do here when I run delete, all right, our transaction has been submitted. And we can see that this message has been deleted because what we did on the back end in the after agreement terminated callback is set user data to an empty string. And then if you want to start this process all over again and create additional flows in the back end, what we can do, maybe we want to instead hodl BTC when we create a flow this time. I can then make a call to our NFT. This will take a second to process through, but all I'm doing is I'm just continuing to pass this user data in along with my call to create a flow, and I can then use that information. That's the key point, right? I can pass anything I want as user data, and I can use that for interesting things. Boom, hodl BTC. So again, very simple example there on the back end and how this actually works. If you have any questions on how that works technically, please feel free to reach out to our team. We want to see interesting things used within this extra metadata field, right? That's partially why it's there. You know, if you think about how many things would be interesting to pass as additional values into some of these agreements, the surface area gets pretty large, right? So from things around advertising and payments, like I mentioned earlier, to paying employees. Maybe you want to append metadata to employees. Maybe you want to add additional data when you distribute funds to a pool of participants in an instant distribution agreement. Maybe you have some kind of extremely exotic thing where you want to compile smart contracts down to bytecode and embed them there as well. It's all up to you. We just want to give you the tools to be able to create those things. So the final thing I'll do very, very quickly is go through how I built the front end. Again, I mentioned this earlier, but I left a lot of the other Scaffold-Eth functionality in here for you to have and play around with in case you want to use some of those extra functionalities. I've commented out most of the other Scaffold-Eth items and just added a couple of variables. So one of the things that I did is inside of our React app, I have inside of app.jsx, I've used the hook from eth.hooks, the use contract reader hook. I've used this to, instead of just grab that purpose value inside of your contract, you'll see inside of hard hat, if you look at the other contract there, the example from Scaffold-Eth, there's just one value there. It's called purpose. It's just a string, right? And you'll see inside of this file that you can just, they essentially just let you grab that value out. This use contract reader hook really just lets you read from a function or any kind of public variable from a smart contract. That's what we do here. So we want to see the receiver, set that as the billboard owner so that we can pass this up here. And then we also want to grab user data to get our message and then pass it here. So what I've done is very simply, like I said, commented out much of the rendered material down here, with the exception of this title of NFT Billboard. And I've created a copy of the example UI component. Where's example UI here? Let's look this up. I don't know if example UI is listed here anymore. I believe I just might have removed it wholesale. But the idea is that I have just created a new component based on the example UI component listed inside of Scaffold-Eth, and then passed in some new properties. So for example, if we go into views Example UI is what I've referred to. Instead of using example UI, I've literally just copied this wholesale, created an NFT Billboard, and then kept all the other variables passed in, but added a couple of new things like message and billboard owner. So you'll see here in the message H2, I'm passing in our message. We can see that here. And then inside of the address component, I'm passing in the billboard owner right here as our address. And then you'll see that inside of the address component, Scaffold-Eth does a good job of creating some nice formatting for you. So we have this whole function component here. This is what essentially renders this with better formatting. And then the final thing I've done is back in the NFT Billboard file. I just had this address component again here where I'm listing the billboard contract address, and then I'm just using some logic slightly changed again from Scaffold-Eth from what they've already had to render this billboard contract address here. So again, front end is very simple. It's just designed to give you a nice little visual example as we go through some of the technical backend work in Solidity. Feel free to get creative, fork this, build your own things, and please do not hesitate to reach out to us with any questions. You can find me on Discord at SamF with a little divider, Superfluid, and then my number handle is 0902. So please feel free to reach out. I'm happy to help with whatever you guys need, and go make interesting use of user data. Thanks so much.